In this video presentation, we will be looking at inequalities. With inequalities, we have some symbols that we normally use, and we're looking at this one, that one, and this one can turn like that and like this. Well, how I look at this is we can read each one of these from either side. So I could read this from this side, I could read it from that side, I could read this one from this side, I could read it from that side, and I could read this one from this side as well as that side, and so for this. What I'll say though, let us say I'm looking at this symbol. If I have x here, and I said x is less than 5, because whenever it closes towards where I'm reading from, I say less than. Whenever it close to it. So like this, it's pointing to the x, I'll say x is less than. But if it opens from where I'm reading from this side, I also could say 5 is greater than x. So in the same breath that I'm saying x is less than 5, I can also say 5 is greater than x. So depending on which side I'm reading from, I might say less than or greater than. It means then that this sign is the same as that sign, depending on where I'm reading it from. Now, another aspect of these signs actually occurs when we have a double bar underneath it. And this one states that there's an equal. So if I'm reading it from this side, from left to right, right now I'll say y is less than or equal to -3. But if I'm reading this from that side, I'll say -3 is greater than or equal to y. What does this actually mean? Well, this is actually saying that -3 is a part of the solution. Because with inequalities, it is not just an answer. It's a range of answers that we're actually looking at. Take a closer look at x is less than 5. Now, if we say x is less than 5, on my number line, here is 5, here is 0, and then I have -5 on that side, and it goes on like that. Now, my marker is at 5, right? So, what this is saying then is that the answers are less than 5, which means that 5 is not a part of my solution. Because 5 is not a part of my solution, this math is actually saying that all the answers that I'm looking for is actually to the left of 5. So my answers are pointing in that direction. I'll use a broken line here because 5 is not a part of the solution region. The region is to the left of 5 on the number line, and every other number coming that way to -infinity. Now let's look at the other one. What if we have a case where we're saying that y is greater than or equal to -3? What are the solutions for that? Well, let's put this on the number line. So on the number line, my marker will be at -3. I will use a solid line, not a broken line, because I'm saying that -3 is a part of my solution. Therefore, greater than. So all the solutions starts at this line and it ends in that direction all the way to positive infinity. Let's look at the third case. What if I see where x is less than or equal to, say, -1, but greater, but alright, also less than or equal to, say, 3. So x is greater than or equal to -1, but it is less than or equal to 3. Well, let's look at that idea. Here is -1, and let us say here is +3. We're looking at the fact that x is between these two numbers. The solutions that I'm looking for, and I'm using solid lines because -1 is a part of the solution as well as +3. The solutions that we're looking for is in this area. All the numbers we're looking for, they are between this area, including -1 and +3. They are in this area, between that. Because it's less than, so it's going to be on the number line. You're dealing with all of these values from +3 all the way to -1, including -1, between those areas. And the reason why I include 3 and -1 is because we have equal on the inequalities. Alright, thank you for watching.